Our group has been focused on asking the question, how do we use product innovation for preventing needless blindness through both innovations on software as well as on the hardware side. In doing this, we focus on two to three key research areas. One is, how do we bring ophthalmic screening to the last mile? So we do that by bringing on-the-edge AI algorithms that are usually ported on simple to use devices that detect the presence of patients with diseases that can be triaged in the last mile. These are devices that can be used by ASHA workers, can be used by optometrists, can be used by healthcare workers, as well as in the case of a few states, we've also looked at Skill India programs through which we've actually trained some of them to use these devices. The second is an ophthalmologist in a bag, where we basically have a portable slit lamp, portable fundus camera, autorefractometer, as well as AI algorithms that allow for anyone to be able to screen through simplicity as well as the affordability of these devices. So you can think of this as a vision center in a mobile bag, which allows you now to be able to not only reduce the cost of setting up vision centers, but now the person operating these devices is someone that can be easily trained and can use these devices. So what we're going to be talking about today as a product launch is a 3-in-1 AI, where a single image of the retina will allow us to now be able to detect for the presence of referable glaucoma, referable diabetic retinopathy, and referable macular degeneration. Of course, the device also has a capability by which it can send all the data to your central EMR so that you don't lose patients to follow up. So you have a software that collects data from all devices, and you also have information with respect to where the follow-up may be needed and which patients and their details. The second area of research for us on where we are trying to improve current practice patterns is, how do we improve efficiency within the clinic? In this, we have developed automated multimodal devices, and today we'll be talking about widefield imaging devices that will allow an ophthalmologist to basically task shift. How do you now get your optometrist to not focus on refraction alone, but maybe have him move more into imaging, and at the same time, with the advantage of multimodal automated devices, how do you actually have someone be able to do these tests that would normally require an experienced optometrist to do these tests, not to be necessarily done by them, but with the help of reports generated by these automated devices, they're able to say whether there's a need for a specialist referral like a glaucoma specialist or a retina specialist, or if there's a cornea refractive specialist, especially in institutes where it may be very difficult to manage workflows. The widefield imaging device is a way by which you now can look beyond 45 degrees in a traditional fundus camera design, and also in a scanning laser ophthalmoscope design, where for the first time we'll be talking to you about devices that can go down to very small pupil sizes like 1.5 millimeters, which is really what you have with in the Indian population, as well as where you have a lot of dark iris cases. So first up, the 3-in-1 AI usually can be missed by an ophthalmologist on a fundus photograph. Lastly, we are also having, through the same image, the detection of those kinds of pathology changes that are indicative of referable AMD. So this is to give you a sense of the various clinical validations that were done. We have close to 17 papers that were published in community as well as tertiary centers and standalone diabetology centers for the referable diabetic retinopathy algorithm with very high sensitivity and specificity, which exceeds the FDA mandated minimum sensitivity and specificity of 92%, of 82.5% and 85%. So we are well beyond that in case of multiple studies that we have done, not only in the Indian ethnicity, but we have also done these studies outside of India as well and across cameras as well. The second is, these are studies that were done at Arvind Eye Hospital, Pristine and Narayan Netralaya, where we were able to pick up patients with referable glaucoma who were detected in vision centers, and the same patients were taken to the main base center, subjected to the entire workflow of a glaucoma workup. But just using fundus images and the AI, we are able to show that the AI was able to do with an accuracy of around 92% compared to a general ophthalmologist or a non-specialist needing to necessarily do around 60% if they are only given fundus images. Of course, if they are given the entire battery of tests, they come back to the same 92%. So the advantage is you can now use this in the last mile with someone who's not an ophthalmologist to be able to pick up. At the same time, within a general ophthalmology context, the idea is how do you actually look at cases where you may now be able to pick up referable glaucoma, especially without the need for expensive additional automation such as or additional devices such as OCT and perimetry. The last is, this was data that was done in Arvind Eye Hospital in Chennai, and this is basically showing the sensitivity of detection of the AI algorithm for AMD, where it was combined, it was compared against the combined grading of OCT and fundus and the grading by fundus images alone. And once again, the AI performed with a very high sensitivity for advanced AMD and also did exceedingly well on both the sensitivity and specificity, irrespective of whether it was compared with OCT plus fundus or whether it was compared to fundus images alone read by a specialist. What this is now enabled is you can essentially have someone take a comprehensive bag. This bag has not only a fundus camera with these AI algorithms, which do not need internet for the utilization, and you can get all of these results coming to the base hospital. And at the same time, this means that you now are able to increase the workflow efficiency of getting more people who may be in need for treatment coming to the base hospital. The second that we are looking at is the launch of widefield imaging devices, also called the Pristine series. We have two of them that we are launching today. One is what we call Pristine 1.5. One of the biggest challenges with SLO based devices has been that unlike, let's say, maybe optos alone, most other devices have not been designed for the Indian pupils, which are much smaller. You have to come down to 1.5 millimeters as a result of the way the ethnicity based differences in pupil sizes are. So the challenge we took on is to ask the question, how do we do 133-degree field of view in a 1.5 millimeter pupil, and how do we do it with true color? So what we have here is a launch of a product called the Pristine 1.5, which we'll actually be launching today as well, which is a non-mydriatic 1.5 millimeter SLO device that allows you to be able to take 130 to 133 degrees in a single shot, and it allows you to be able to then put these together in terms of a montage as well. So that, for example, is a true color image that you would get from the device, where the true color is actually generated as a result of us being able to use AI to be able to recreate the true color. It also offers modalities such as autofluorescence as well as red-free and infrared imaging. So these are, for example, pictures that you'd get from the device. It also allows you to, it has an auto montage function by which you will be able to take multiple views of the retina, including the inferior and superior, and then it automatically stitches the image as well to get a much wider field of view. Now, what does this enable for a retinal physician or a general ophthalmologist in their practice? One, how do you ensure high quality imaging in a dark iris patient with a very small pupil? Second, it helps reduce patient wait times without the need for dilation and for photo documentation. The affordability also brings the device into pre-LASIK and pre-cataract workflows. And of course, one of the challenges that we have taken on is to essentially allow for doctors to come and get themselves imaged, where we have a challenge where we have a 5,000 rupee gift voucher for any doctor whose eye we are unable to image because of pupil size. So please do come and get yourselves experienced on the device, because it is a way by which we are also able to stand true to what we claim. The other that we are looking at is another version of the widefield imaging device called Pristine 5.0. The intent here is, this is a device that we actually have developed in partnership with Seva Foundation of the US, where the idea was to ask the question, how do we come up with a low-cost widefield imaging device for a general ophthalmologist? So our target was to come close to the 10 lakh price range. And the way we've been able to do this is basically by having a very high-end camera at the back as a sensor. However, this requires dilation. It needs a minimum of 5 millimeter pupil, which is the reason we call it Pristine 5.0, which is the size of the pupil needed for a widefield imaging. The advantage that you have with this system is threefold. One, because of the high quality sensor, you get extremely high resolution images where you can see both the nerve fiber layer as well as extremely small dot plot images very easily. The second is it again has automated montaging. In a single shot, you get 60-degree field of view, and of course you can automate the montaging by which you are able to go across to 80 by 115. This was a paper where in Dr. Mohan's Diabetes Center, they compared the Optos versus this, where they did find more lesion detections happening with the Optos. The staging of the disease did not necessarily change so long as you were actually past the ETDRS field of view that you needed. which is what we were also able to show with this device. It has features such as auto capture as well as auto montage as well as autofocus that allows a very simple use where you don't necessarily need to train someone to actually use these devices. The other is we also realized that you need a way by which if you are using the device, you can automatically take the pad and have a discussion with the patient in engaging them, and post that as well. The QR code on the report allows you to actually customize, let's say, a video that you could have where you can essentially make sure that you can talk about the various diseases so that they can use the QR code and then learn about those diseases even after they have left the clinic. So those are some of what we have brought in here, and that's what you would see as workflows that you get to know here. Again, the intent is to increase engagement of the patients, even as we know that they are being screened for or managed for a variety of retinal conditions. So these are, for example, images that you get from the device. This is, of course, two field. A single field gives you 60 degrees. And if you were to go to a four field, you get 80 by 115. Which is essentially the visual angle that you essentially get with the use of these devices. The high resolution essentially ensures that you have a lot of detail in the images. At the same time, we've already talked about the auto capture as well as the QR code that we have on the reports. So with that, we'll stop for questions that you may have, and of course we'll request Dr. Taraprasad Das to formally also unveil the devices, because we have a formal launch also of the device here.
But I just wanted to also get your perspective in terms of how it would be helpful from a clinical perspective to move from the traditional 45 degrees to wider field, and how the technology has been evolving from a clinical perspective.
Well, there were two things here. One is that how long patients should stay in your office. The world when there is a 30 minutes pizza or it is free, 10 minutes burger or it is free, is incorrect to bind the patient for longer hours. We have no opportunity to do this in past, is a different story, but today we can have actually smaller people, undilating people, you can examine the entire retina or at least most part of the retina. The devices that was available till now before this one came, unfortunately were not real small people, not for Indian Asian eyes or South Asia eyes. For example, my people, if I go there, I have to earn a lot, struggle a lot. If I come here, I know I can do it. That's one. And two is that should you dilate everybody and examine the retinal periphery? Retinal periphery examination not just for diabetes. Let's say somebody wants to go refractive surgery. Do you want to see the peripheral retina? You are not trained to dilate, examine or use ophthalmoscopy properly, then machine can help you. And of course, you know what happens in retina patients. There are innumerable papers that says that peripheral retina as important as the central retina or mid-wide field retina, because many times lesions could be there. Let's say classic example, retinopathy of prematurity, hardly anything happens, most happens in the periphery. If you have forgotten that, you cannot examine, you have forgotten everything. Though it may not be always useful to examine the peripheral retina also, without the troubling patient to stay longer in your hospital, from his benefit and also your chair time benefit. From that point of view, I am happy. Now, should you use a flash camera? I will be reluctant, because flash camera cannot actually take all the images and then you are troubled. SLO is certainly better than a flash camera. And number two is how wide is the wide. 200 wide required, or you can, many pictures you can take, combine them, create a mosaic and still create a 200 thing. The good part of this new cameras are that true color. Instead of a pseudo color, to paint something, this comes how we like to see our retina doctors. From that perspective, the newer devices are very, very good. And this is Remidio is famous for handheld portable devices, but both of them are not portable, I know, but then you can't make a portable SLO based camera today anyway. So from that perspective, Divya will agree that both are useful. Currently, I know this is being used extensively in Africa for HIV patients, and this is not yet started, but this will be extremely useful armamentarium for our future care of ophthalmic patients. I'm not talking diabetic retinopathy or retina group alone.
Thank you so much, TP. So I think we all heard how workflow efficiencies, and also from a clinical perspective, there are several retinal conditions where it's not just posterior pole, there are a lot of peripheral lesions that happen. The stage of diabetes can actually change if you see peripheral retinal lesions and neovascularization, etc. that can be missed, especially in cases where you're treated patients with PRP and then you again see rebleeds, etc. It's very important to examine peripheral retina vasculitis, peripheral retinal degenerations. But as TP rightly pointed out, I think even in the regular workflows for cataract workup, refractive workup, examining the retina is becoming part of the mandatory practice. TP also wondering how the landscape of screening is also evolving. Do you see it also moving to wide field?
Well, many years ago, there is a beautiful paper published for the first time in India, where this camera, not this camera, but the handheld camera, was used and published in JAMA Ophthalmology, I think 3-4 years ago, that working in a slum area of Bombay, how this has improved the detection of diabetic retinopathy. So this camera may not be able to carry to a field all the time for smaller areas, but what has Remidio has done is putting the AI not on the cloud but on the edge. So that means even a naive guy who is not a trained ophthalmologist or optometrist can actually knows how to take a photograph, then AI will help, are you referable, not referable. Like our 3 traffic signals, green, orange and red. If it's a green, okay, it takes 6 months, 3 months to go to doctor. If it's orange, within a week, within a month you go there. Red, please run tomorrow and get examined. I have personally been imagining this kind of a simple solution for the patients, because talk about diabetes alone. At the publication of last year, July, by Mohan Group from Madras, 100 million people have diabetes. That IDF projected you might get 74 million. We have beaten it all over. We are now 100 million. 100 million diabetes, by simple arithmetic, 30 million will have retinopathy and 10 million will require treatment. And 30 million people with a 28,000 ophthalmologists, what yesterday they announced by Samar Prasad and other people, how can examine patient at all? 30 million, 30,000 doctors just cannot examine. I'm not talking retina alone. So screening is important. In a screening, suppose you burden the ophthalmologist to screen all the patients all the time, you cannot, because I told 1/3 require treatment, not all the 100%. So screening is important so that you know whom to screen. Now, with the help from Medical Research Foundation from UK, we did a huge study and published several papers. Last we published March of this year, March 1st on Lancet Diabetes, Lancet the Global Health. 12.5% of the people have got diabetic retinopathy, and 4 million people in the country right now require treatment. Now, to treat 4 million people, can you examine 100 million people actually? That is why the screening is important. If only 25% required treatment or 5% required treatment, then somebody has to screen. The screening guy should not, we don't have manpower, should be a guy which is a less trained, not necessarily an optometry, vision technician, ophthalmologist, definitely not. So they refer. In a referral case, whatever AI does it, they will make a 5% to 10% mistake. The mistake is towards the false positive, I'm fine, because you overdiagnose something, still you can do it. Underdiagnosis is very, very bad. So that's why specificity, sensitivity is very important when you design something. So I will go for the screening, but screening by a non-technical person, very technical person. So like WHO talks about tier system of a integrated people-centered eye care, screen in the lower level, community level, then you re-diagnose in the secondary level, treat in the secondary or tertiary level. That way, India can manage 100 million diabetes, otherwise it cannot. Did I answer you well?
I think you made a very interesting point in terms of the number of diabetics that need to be screened. I was just wondering, TP, now, if you have the same risk cohort, wherein you know diabetes can also lead to multiple other conditions, how do you think it would be advantageous to screen for multiple conditions in the same group, and why do you think that's going to be important?
Well, unfortunately, diabetes has your own brothers and sisters. They all come with hypertension or kidney disease or foot problem or heart problem. The study we did called the speed study in India several years ago and published 5 papers out of that. We said that 56% of people in India, irrespective of which zone are living, north, south, east, west, have got hypertension. Then many of them will have a kidney disease and heart disease, etc. Now, using the fundus images, particularly the posterior pole and the vessel caliber, vessel configuration, and the class, most probably AI will be built or the building to suspect other lesions in the body, which also happens with diabetes. So, like this, just like Anand told that take one photograph, you can do a referable glaucoma, AMD, and diabetes. Similarly, you can have a referable heart and kidney or something else, which is necessary from the patient perspective because they don't want to go 10 places to do something. Let's say I have a fever, I don't have to go to a malaria doctor, typhoid doctor. One doctor can diagnose something. So AI could be harmful also, AI could be beneficial also. So I will go for a system where you can suspect, not diagnose, suspect that another body condition, because diabetes doesn't come alone and diabetes is systemic disease, not an eye disease actually, and it will certainly be useful. And already happening, Google others are doing it. I'm sure everybody will do ultimately. Maybe another 3-4 years from now, that will be reality. That fear is that, like this machine, you diagnose yourself and doctor will say what will happen to me. But I don't have that fear at all. Take example of a simple thermometer. As an MBBS student in Odisha, I had to learn from a nurse with difficulty how to read a mercury thermometer. By the time you become resident, it becomes slightly better because you can read something. Now it is all digital. So now I know that if I have got a fever of 99.2, I have taken Dolo. If I have got 100.5, I will be cautious, lie down for a while. 101.3, I must run to a doctor. So giving the power to the patient is very, very important. Let them decide what they want. I am waiting for a day when patient will say, did you examine my eye pressure with a appellate thermometer because my father had a glaucoma? Did you examine my retina because my mother had a diabetes? So that power still do not have that. So this one will give the power to the patient to question. 1980, when we started intraocular lens implantation, I was in Madurai those days. Patient will ask that, is it safe and is it imported? But today, patient will say, are you not doing IOL? We are not doing toric IOL because of advocacy. So this will also happen that way, that patient will be powerful to ask questions. That will make us also alert. We cannot fool around anymore. So giving the power to the patient is nothing wrong in that, but you should know that when to give and when not to give also. Divya.
I think some great points there, TP, where you said empowering the patient with information is important, but making them, it's sort of a balanced way in terms of giving them enough information. And the other point of looking at multiple conditions, like what we're doing right now with DR, glaucoma and AMD, and going much beyond that because eye can be a window to systemic illness. And watch out folks, I think that's where we are heading towards, and it's going to be an exciting phase going forward. Thank you so much, TP, for your time.
But caution is that don't be afraid about the AI or new devices, because this will not unemploy any of us. That fear is always, will I be unemployed? No, you won't be unemployed at all. Another advantage that we have got on the edge AI, then physician doesn't have to send a photograph somewhere else. Patient can, she can kind of propose that this is referable, not referable. I am going to invite Satish Gupta because one of the early stage Indian innovators. And Satish, आप ना बोलोगे तो अच्छा नहीं लगेगा. Ask questions. Oh, Divya will ask questions. Okay. No, I think Satish is very, 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 very humble. Very humble.
I think not many people know, but at least for folks within Remidio, one of the earliest papers, sir, I have read of yours, where you had a digital camera that was modified, where you started taking pictures using that. So we've seen that optical design and we've seen how you've looked at it from there. So I guess one of the key things is someone who's also been on the technology side, where are you seeing the challenges in terms of mass adoption? Like if tomorrow, if the clinical part is well understood, whether we talk about ophthalmology or whether we talk about a primary care, is technology the problem or is awareness the problem or is it, how do you actually message this, or where do you see the challenge? Because I know that you've been thinking about this. That paper I think was in 97, 98, way 96. Yes, I remember that. So which is the reason why I wanted to ask you as someone who has been on the technology side.
The challenge mainly, technology is not a challenge now. It's mainly the awareness and taking it up by the primary physicians. That is the main challenge. Because unless the primary physicians take it up, they have a fundus camera in their clinic and they can do screen every patient, not only for diabetic retinopathy. Now it is being proved that for other heart conditions, liver conditions, other conditions also, it is very important to fundus picture in the diagnosis.
Anand, same question to you. Don't run away. Anand is from Nagpur, my friend from Jipmar days in Pondicherry.
And the current Prime Minister is so keen on adoption of digital technology, one thing. Second, make in India thing. I'm glad that Anand with his super fertile brain and his application dedication has brought these things in the form of these two screening devices, which will, even if it can prevent 5% of the diabetics from going into the end stage of diabetic retinopathy, even if it can detect 7% of the AMD patients and prevent 5 to 7% of people going blind from glaucoma, I think the purpose would have been served. What is very important is, am I audible, sir? Now. Dr. Anand Sivaraman has already told us about the specificity and the ability, sensitivity of the device, and the fact that AI could detect certain things much better than an average ophthalmologist. That is a little scary, but I don't think that there is any need to panic. AI should be not our master but our tool, one of the tools, and I'm sure that this will help Indian ophthalmology to set a big footprint on the world ophthalmic scene, and of course help India tackle the number of the millions and the disease burden. I say we must give him a big applause. Thank you for this opportunity.
Thank you so much, everyone. At the end, I think it's a team of us, including the ophthalmologists who have been part of our journey, I think, since 2009 and 10. And one of the things that we are also doing to the question on the primary care physicians, over the next 3 years, we are partnered with Sun Pharma with the intent of reaching out to 2,500 endocrinologists and diabetologists, where primary eye care screening will be done using AI as well as the non-mydriatic retinal cameras. And so we are hoping that that's going to essentially have at least 12% of those that are detected from that moving into the workflow pathways of the ophthalmology clinic. So sincerely looking forward to that. With that, please come, you can take a demonstration. We have one who's dilated and you can see the images real time, and of course the undilated, you can get yourself imaged or anyone imaged as well. But thank you so much everyone. Thank you so much, Dr. Vinod.